Section 2.4 will cover the subatomic particles that make up an atom or ion. Specifically, we'll cover the different components of the atom, their masses, charges, and how it affects placement on the periodic table. We'll also discuss isotopes, work with isotope notation, and write the isotope notation for neutral atoms and ions. Let's begin. Protons, neutrons, and electrons are called subatomic particles. The atomic nucleus itself is incredibly tiny, with a radius of only 1/10,000th the radius of the atom itself, but contains almost all the mass of the atom. Electrons have very little mass, but occupy almost all the volume of the atom. The symbols for each subatomic particle are noted in the table, along with the masses in atomic mass units, U, which is based on the mass of a carbon-12 atom and is discussed in the next lecture. Note that the mass of an electron is roughly 1/2000th the mass of a proton or neutron. Putting this in terms we're more familiar with, if an electron had the mass of a marble, a proton or neutron would have the mass of a bowling ball. Similarly, if the tiny nucleus were the size of a marble, the atom would be the size of a stadium. Atoms are electrically neutral because the number of protons, P, equals the number of electrons, E. Because the number of protons determines the identity of the element, the number of protons is called the atomic number, Z. The atomic number of every element is given as a whole number on the periodic table. For example, Z equals 1 is hydrogen, and Z equals 8 is oxygen. The number of neutrons in the nuclei of atoms of the same element can differ. Two atoms with the same number of protons but different numbers of neutrons are isotopes of the same element. Isotopes have the same atomic number, but they have different masses because of the different numbers of neutrons. Each isotope of an element is usually identified by its mass number, A, which is the sum of the protons and the number of neutrons in the atom. Symbols and names for isotopes include the element name or symbol and the mass number. The mass number goes on the upper left quadrant of the element symbol, while the optional atomic number, which is implied by the element symbol, is noted in the lower left quadrant. The isotope of hydrogen with 1 proton and no neutrons is hydrogen 1, or 1H. The isotope of hydrogen with 1 proton and 1 neutron is hydrogen 2, or 2H. Let's work through a couple of these together. For convenience, I've included a couple of snippets from the periodic table. How many protons, neutrons, and electrons are in a neutral atom of sulfur 32? The number 32 gives us the mass. The atomic number gives us the number of protons. So 16 protons and 32 minus 16 equals 16 neutrons. The atom is neutral, which tells us we have 16 negatively charged electrons to balance out our 16 positively charged protons. Fluorine-19 has an atomic number of 9. This tells us fluorine has 9 protons, 19 minus 9 equals 10 neutrons, and 9 electrons. If we consider a neon atom with equal numbers of protons and neutrons in its nucleus, we see neon has an atomic number of 10. This gives us 10 protons, 10 neutrons, and a mass number of 20. It will take 10 electrons to make neon electrically neutral with its 10 protons. Finally, let's look at a heavy element, U-238. Since the atomic number is given, we really don't need the periodic table snippet, but I've included it here for comparison. An atomic number of 92 tells us uranium has 92 protons. The atom is neutral, so it has 92 electrons. 238 minus 92 gives us 146 neutrons. Now that you've gotten some isotope notation practice under your belt, can you tell me what is wrong, if anything, with each of the isotopic symbols? In A, the mass and atomic numbers are flipped. B is correct, as it's noting a heavier isotope for oxygen than the one shown at right. C is incorrect because the atomic number for hydrogen is 1. D is incorrect because the atomic number for nitrogen is 7. E is also incorrect since the atomic number for sulfur is 16. So any mass numbers must be greater than 16. The number of electrons will not always match the number of protons in an atom, leading to the formation of an ion. Ions can be positive cations, such as when sodium loses an electron to become Na+, or ions can be negative anions, such as when oxygen gains 2 electrons to form O2-. How many protons and electrons are in each of the following ions? If you haven't already, it's time to grab a periodic table. Fluorine has an atomic number of 9, so a neutral fluorine atom has 9 protons and 9 electrons. When an element forms an anion, it gains electrons. With a -1 charge, the F- ion must have 10 electrons. Magnesium has an atomic number of 12, so a neutral magnesium atom has 12 protons and 12 electrons. When an element forms a cation, it does so by losing electrons. Magnesium has a +2 charge, indicating the loss of 2 electrons, so Mg2+ has 12 protons and 10 electrons. Nitrogen has an atomic number of 7 and forms a -3 ion. Therefore, nitrogen with a -3 charge contains 7 protons and 10 electrons. W is tungsten with an atomic number of 74. Tungsten loses 6 electrons to get a +6 charge, so W + 6 has 74 protons and 74 minus 6 equals 68 electrons. As always, I'll leave you with the parting thoughts of the authors. Pause here to take notes, if needed, then allow the video to finish playing so your score will transfer to Canvas.